last time we have discussed the shear force and bending moment diagram, and we have seen the diagram for different types of loading, cantilever beam and simply supported beam. Okay? So today we have seen one more example, shear force and bending moment diagram with a overhang beam. Okay? So let's consider example. So one overhang beam, overhang only right side is your hinge support, your roller support, your uniformly distributed load, the 3 meter span, 25 kilometer. One point load of 100 kilometer here. This is also 3 meter span. Another UDL of 25. Okay. So you have to draw the shear force and bending moment diagram of this overhang beam. So first of all, if you want to calculate the shear force at a various section, so we have considered the different section, calculate shear force and bending moment from the left hand side or from the right hand side. Okay. So this is our sign conventional to calculate the shear force. Now, if you consider the section here, intermediately already at this under the point load. So if you calculate from the left hand side, then you want to record these reactions, and if you want to calculate unbalanced force from the right hand side, then also require these reactions. So first of all, we have to calculate the support reaction. Okay. So for support reaction, consider this is the reaction RB, this one is RA. Okay. You have to calculate the support reaction considering the equilibrium condition. So we get RA is 97.9, RB we get 127.1 kilometer. Okay. Here we have read directly, but you have to calculate this reaction. So now consider the different section and calculate the shear force. First of all, consider here one at point B is section 2, just right of B, just right of point load is section 3, and just right of section point A is section number 4. Okay. So shear force at section 1. Now consider the right hand side portion, section 1. So no any loading means total unbalanced force from the right hand side is 0. Then consider the shear force at section 2. So unbalanced force from the right hand side of section 2. Right hand side sign conventional downward positive. So right hand side only 25 uniformly distributed load over a 2 meter span in downward. So total unbalance is 25 into 2, and this is downward, so right hand side downward is positive. So we get 50 kilometer. Okay. Now shear force at section 3. Here. Again consider the right hand side. So reaction RB is upward, 25 into 2 is downward. So total unbalance is right hand side downward positive, upward negative. So reaction RB is upward. So consider minus 127.1 upward. So that's why consider negative. And another force is this 25 into 2 is downward. So 25 positive. So we get minus 77.1 kilometer. That is the unbalance at section 3. Okay. Now shear force at section 4. So now consider the left hand side portion. Okay. Left hand side. So only one reaction is there, RA. And left hand side reaction is upward. So left hand side sign conventional, upward is positive. Okay. So reaction RA is 97.9 is positive. Okay. We try to draw the shear force diagram. So consider the reference line. Initially it's 0. Section 4 is just right of A, means at point A it's become 97.9. So here 97. Now at point section 3 shear force value is minus 77.1. So if you consider the section here, so its values become 77.1. Okay. If you consider the section here, so shear force at section 2 is plus 50. And if you consider the section 1 here, so it's 0, means here 0. So first of all, the instant increase at point O A is 97.9. Now between section 4 and 3, uniformly distributed load. So diagram is decreased linearly. 97.9 constant. Section 2 here reaction RB means in upward directions. Reaction RB is 127.1. If you add minus 77.1 plus 127.1, so you get plus 50 is already there. So you have to connect these two, plus 50. And again between the section 2 and 1 uniformly distributed load. So variation is linear. So our diagram is like this. So the positive is negative and this diagram is positive. Now calculate for the bending moment value. So a sign conventional is this. Left hand side clockwise positive, right hand side anti-clockwise positive. Okay. Calculate the bending moment at section 1 here. Again consider the right hand side part. Right hand side no any loading, so moment about section 1 is 0. Now consider bending moment at section 2 means here. So your section 2 is this, and here right hand side only one loading 25 for a 2 meter span. So their moment about section 2 is 25 into 2, 2 by 2. Okay? And their moment is clockwise. And right hand side our sign conventional is anti-clockwise. So this moment is negative. Okay? So minus 50 kilonewton into meter. Now bending moment at section 3 here. So if you consider the left hand side or right hand side, so you get the same moment. Okay, I will consider the left hand side portion. So left hand side, this reaction RA, they produce the clockwise moment about section 3 and left hand side sign conventional clockwise is positive. So this reaction value is 97.9 and their perpendicular distance is 3 meter. So this reaction into distance clockwise moment 97.9 into 3, this moment is clockwise. Another moment of this UDL 25 kilonewton for a 3 meter span, and that is in anti-clockwise direction, and our sign conventional from the left hand side is anti-clockwise negative. So minus the moment is loading is 25 into 3 into 3 by 2. That is the perpendicular distance from section to centroid of that loading. So 97.9 into 3 minus 25 into 3 into 1.5. So 181.2 positive. Of the bending moment at section 4. Consider the left hand side portion. So 0. Now draw the bending moment diagram. So consider the reference axis. A, C, front section. Now bending moment at 1 is 0, means here 0. Bending moment at 2 is minus 50, means here minus 50. Bending moment at 3 is plus 181.2, so section 3 here. And bending moment at 4 is 0 here. Now you have to connect this different section according to the loading conditions. So between 1 and 2 means this 2 point is connect with parabolic curve because here loading is UDL. You have to connect using parabolic curve. Now you have to connect parabola in two ways. First one is this, second one is this, downward curvature or upward curvatures. But here shear force value is 0, so slope at that point is 0. So that's why we have connect the parabolic curve like this. Now between this section 2 and 3, no any loading, means variation is linear. So you have to connect these 2 points with a line diagram. Again between 3 and 4, UDL load is there. So again you have to connect these 2 points with parabolic curve. But here the lesser shear force value compared to this point. So here lesser slope compared to this point A. So you have to connect the parabolic curve like this. This diagram is positive, this is a negative. Bending moment diagram. Now you can see that here shear force value is 0. So at that point bending moment value is maximum. Here also 0 and here also becomes 0. So at this point here maximum positive and here this point here maximum negative. Okay. Now this point is where our shear force bending moment diagram is moved from negative to positive, or you can also say it's moved from positive to negative. So this point is known as the point of contraflexure, because here bending in this portion is opposite to the bending in these portions, because here negative bending, here positive bending. So at this point these contractions of this upward bending and downward bending, so it's known as a point of contraflexure.
Sir,
Where our bending moment
સર
diagram change the sign. Yes, what?
સર આમાં બેન્ડિંગ પેરાબોલિક કર્વ પેલામાં ફળ કેમ આવશે પેલા
અહીંયા
ઉપર વાળા હા
here shear force value is lesser than this. P is dm by dx. That is the relation between the bending moment and shear force. Consider
યસ
section 3. So here slope value is 22.9, and if you consider section 4, so slope value is 97.9. So here slope is higher compared to this point.
ઓકે સર
So here slope is higher 97.9, and here slope is lesser is
sir,
22.9. Yes.
સર BM3 માં આપણે જે લેફ્ટ સાઈડ કન્સિડર કર્યું તો સર એમાં પોઈન્ટ લોડ 100 કિલો ન્યૂટન બી થયું તો આપણે એને
Yes, but the
કન્સિડર નહીં
distance
કર્યું.
between this section and point load is tends to 0.
ઓકે સર, સમજ પડી.
Just right, that means the distance is tends to 0. So their moment is also 0. So no need to consider point load in bending moment, okay? We calculate the shear force at that time we have calculated. Because here the unbalanced force is, and this is the unbalanced moment. Okay? So in overhang beam, diagram is positive as well as a negative side also. So whenever our bending moment diagram change their sign from negative to positive or positive to negative, so this point is known as the point of contraflexure. Because if you draw the deflection shape of this beam, so it's like this. This is our support condition. Okay? Here the loading is downward, so our beam is deflect like this. This. So this is the deflected shape of beam, because here loading UDL, so they will push the downward. Here also the UDL, here also point load. So the loading is also try to push the beam downward. So here at that point, here curvature is downward, and after that curvature of beam is upward. So here bending in this way and here bending in this way. So at that particular point, bending change their nature, positive to negative or negative to positive. Okay? Bending direction is different from this point. So this particular point is known as the point of contraflexure. Here negative bending, it means our beam is bent in this way. Here positive bending, that means our beam is bent this way. Logging moment, and this known as the sagging. So it's positive, this is negative. Here bending change their directions. So this particular point in bending moment diagram is known as the point of contraflexure. Let's consider one more example. This uniformly distributed curve. And take the screenshot of this page. one support, hinge support, and second one is roller support. Here loading is 25 kilonewton. Here also 25 kilonewton. In between the UDL loads there. This one is 1 meter. This is 6 meter. This one is 2 meter. You have to draw the shear force and bending moment diagram of this beam. Okay. So here also the overing beam. Means if you consider any section, so for that particular sections, if you calculate from the left hand side or from the right hand side, then you have to record this reaction value RA and RB. Okay. So first of all, we have to calculate this reaction value. We here change this value. It's not good. So 50. 50. So calculations is the your homework. You have to calculate this reaction RA, RB. So we get RA is 86.67 kilonewton and RB is 103.33 kilonewton. Okay. Simply you have to apply the equilibrium conditions, find out the support reaction. Now calculate the shear force. So a sign conventional is this: left hand side upward, right hand side downward is positive. So consider the different section. So just left this point is section 1. Just left of this reaction is section 2. Just left of this point A is 3, and here just right this is section 4. So shear force value at section 1. Now consider the right hand side portion. So only one point load 15 kilonewton downward, and right hand side sign conventional downward positive. So here 10 kilonewton. Shear force at point 2 here. If you consider right hand side portions, so one support reaction upward and point load downward. So downward is positive, so 50 minus upward reactions, and their magnitude is 103.33. So we get 15 minus 103.30 minus 53.33 kilonewton. Now shear force at section 3 here. Consider the left hand side portion. Only one point load and it is in downward directions. Left hand side sign conventional upward positive. So this 15 kilonewton is S sign. Shear force at section 4 is all minus 50 kilonewton, because again if you consider the left hand side portion, so downward is positive. Downward is negative, okay, because left hand side upward positive. This is our shear force value at a different section. Now you have to consider the reference line. Section 1, 3, 4. Shear force at 1 is 50, so here plus 50. shear force at 2 is minus 53. Section 2 is here, so minus 53. Shear force at 3 is minus 50. And at 4 is minus 50 again. Now if you consider just right of that, you can also get the another value of shear force. Now consider the left hand side portion of the section 5.5. So you get this 15 downward, so minus 50 load, and this reaction RA is upward. So left hand side upward is positive. RA is plus 86.67. So minus 50 plus 86.67. So plus 36.67 kilonewton. Okay. So section 5 is here. So at that point you get this another value 36.60. Now move from left to right. So first of all section 4 is there. So the diagram is 0 to 50. Then between 4 and 3 no any loading, means diagram is constant. And then 3 to 5 your value is changed from minus 50 to plus 36.67. So instantly increase, because here reaction RA is in upward directions. So minus 50 plus 86.67, this is reaction RA. So instantly increase this. Now between these two sections, UDL load is there. Their variation is linear. So diagram is very linear. And then after, between this 2 and 1, so if you consider another section just right of this, so your diagram is instantly increased minus 53.33. Here, this value. And if you move just right of this, the reaction RB is in upward directions, and that is the plus 1.33.3. So plus 103.33. So it's become plus 50. So at this point, you get also value of 50. Your diagram is instantly increased from here and after constant and 0. So this is a negative positive. If you consider another one section here, 6, so you get shear force at 6, so it's 50 kilonewton. So during the calculations, you need to require one more sections in between 2 points. So you have to consider one more sections and calculate the shear force value. According to that value, you have to draw the diagram. So you can easily get the variation in shear force diagram incorrect. Now bending moment. This is the sign conventional of bending moment. Left hand side clockwise, right hand side anti-clockwise is positive. At this point, the bending moment value is maximum or minimum. So first of all, you have to calculate this point where our shear force value is become 0. So using the similar property of these two triangles, you have to consider this distance is x. So this remaining distance is, total distance is 6. So this remaining distance is 6 minus x. Now using the similar triangle property in these two triangles, you have to find out this x distance. So you get this x is 2.445 meter. That means you have to also calculate the bending moment value at a 2.445 meter. So consider the bending moment value at 1. Now consider the right hand side portion of section 1. So no any loading, this moment value is 0. Consider this section 2. Consider this section 2. So right hand side only one point load 50 kilonewton downward directions. So this produce the clockwise moment, and right side sign conventional anti-clockwise positive. So their moment value is negative 50 into their perpendicular distance is 2 meter. So minus 100 kilonewton into meter. Now bending moment at this section is 2.44 meter from point A. So say that this is the section XX. Here our shear force is become 0. Okay. So bending moment at X. Consider the left hand side or right hand side. So you have to apply this sign conventional according to left or right. Consider the left hand side portion. Okay. The left hand side sign conventional clockwise positive. So at section XX, this 50 kilonewton produce the anti-clockwise moment. So minus 15 into this distance is 1 meter and this distance is 2.445. So this total distance is 3.445. Another this force is this reaction at A. This produce the clockwise moment about section X. So left hand side clockwise is positive. So plus this reaction value is 86.67 and perpendicular distance is distance between this A point and section XX, and this value is this 2.445. Another moment due to this UDL up to section XX, and that will produce the anti-clockwise moment. So minus 15 UDL into 2.445, that is the total UDL left hand side of that section XX into 2.445 divided by 2, that is the perpendicular distance from that section XX. So you get total value is minus 5.17 kilonewton into meter. Consider the bending moment at section 3. So at section 3, consider the left hand side portion. So 15 into 1, and that is in anti-clockwise direction, and left hand side clockwise is positive. This moment is negative 15 into 1. Let's try to draw the bending moment diagram. Bending moment at 1 is 0, means here 0 value. Bending moment at 2 is minus 100, section 2 is here, so here minus 100. Bending moment at X 5.17 minus, so here this point. Bending moment at 3, that is minus 50, so section 3 is here minus 50. Bending moment at section 4 is 0. Consider left hand side portion, so any loading, so moment at section 4 is 0. So between these 4 and 3, no any loading means you have to connect a linear variation. X is UDL. So this is also UDL. These 2 points is a UDL curve, but maximum value is this. So you have to connect like this. And then again between these two sections, no any loading between the 2 points. So variation is again become linear. So whole diagram is negative. Here our whole diagram is negative, means no any point our diagram change from negative to positive or positive to negative. So here we not get the point of contraflexion. Okay.
સર
Yes.
સર આર અને આરબી ની વેલ્યુ સર ડિફરન્ટ આવે છે આમાં ફાઇન્ડ કરીએ તો
When different. અહીંયા મોમેન્ટ કન્સિડર કરો તો શું થાય? 15 into 1 anti-clockwise, RB into 6 anti-clockwise is equal to 15 into 6 into 6 by 2 clockwise plus 15 into 6 plus 2 means 8 clockwise about point A. Consider the summation of moment about A0. 15 into 1 anti-clockwise plus RB into 6 is equal to, this anti-clockwise is equal to clockwise. So 15 into 6 into 6 by and plus 15 into 8. So you get the RB 03.33. Okay.
ઓકે સર
In this way, you have to draw the shear force diagram for overhang beam. Okay. So whenever this overhang portion is given, so at that time you have to consider the same line convention, and according to the negative or positive value, you have to connect this different diagram. Let's see more example.
Excuse me, sir.
Yes, bro.
Here is Gopal Goyal. I think, sir, it is 942.
942. Okay. 950 સુધી છે ને સર લેક્ચર? Yes, ગોપાલ સર.
હા સર
9:15 સુધી છે ને મારો લેક્ચર?
કેટલા સુધી છે તમારે?
9:15 સુધી.
10:15 સુધી છે? Just a minute.
9:15 સુધી છે. 9:50. 9 to 9:50. in different way. Shear force and bending moment diagram is asked that shear force diagram is given to you and you have to get the loading diagram from this shear force diagram. Okay. First of all, I'll draw the shear force diagram. This is the shear force diagram. Okay. Span is 3 meter. Span is 1 meter. This is 1 meter. Span is 2 meter. Okay. So the shear force diagram is given to you. You have to draw the loading diagram from shear force diagram. So you have to do the reverse process of the previous example. Okay. So first of all, you have to see this diagram. So you get the idea about the loading between the different points. Okay. You say that this is the point A, B, C, D, E. Okay. So if you see the diagram between point A and B, so here variation is linear. That means you can say that the loading between point A and B is uniformly distributed load. Okay. In between B and C point, diagram is constant, means no any loading. And at point C, its diagram instantly decrease from something value from 9.6 to 21.6. That means here point load is there. Again between C and D, no any changes, means constant, so no any loading. And at point D, it's instantly increase, means upward point load is there. And then after between D and E, again variation is linear. So again the loading is uniformly distributed load. Okay. So if you want to get the loading value, this is the point A, this is point B. Span is 3 meter. Okay. So from A to B, okay, change in the shear force value is plus 14.4 to minus 9.6. So change in the value. So 14.4 minus plus 9.6. So we get 24. Okay. Now changing the shear force between these 2 points is 24. And total span is 3 meter. Means 24 kilonewton load you have to distribute in 3 meter span. So W is 24 by 3 kilonewton per meter. So 8 kilonewton per meter. So you have to apply here loading 8 kilonewton per meter. And here instantly 0 to 14.4 means one reaction is there. Okay. Now between B and C, no any changes. Diagram is constant. So between B and C, no any loading. But at point C, instantly decrease 9.6 to 21.6. So change in the shear force is 21.6 minus 9.6 means 12. So here 12 kilonewton. Because here instantly change in diagram, that means represent the point load at that particular point. Okay. Now again at point D here, minus 21.6 to plus 24. So total difference is 24 plus 21.6, 45.6. So that is in upward directions because from negative to positive here. So your reaction is upward directions. 5.6. And then between D and E, again the change in the diagram is 24 and total span is 2 meters. So this 24 kilonewton changes you have to distribute in 2 meter span. Means here the loading is UDL, and 24 by 2 that is 12. 12 kilonewton per meter. This is the loading diagram. Okay. And these two reactions is represent support. So from that shear force diagram, you can get the bending loading diagram. Once you get the loading diagram, then after you can easily draw the bending moment diagram. Because now loading diagram is available to you. So you have to calculate the moment value at a different section and draw the bending moment diagram.
Hello, sir.
Yes.
Sir, 14.4 minus 9.6 કેમ થયું?
Total
For
change
equal
in
to
the shear force diagram between these 2 points. So here diagram is plus 14.4 and at point B is minus 9.6. So what is the change in diagram between these 2 points?
okay, sir. Difference, sir.
So loading is there. So according to this loading, your diagram is changed. So we get
Yes,
the
sir.
loading value from the change in the shear force value.
Okay, sir.
Same way you can get here also. Here plus 24 and 0. So 24 and span is 2 meters. So 24 by 2. So you get 12 kilonewton per meter uniformly distributed load. This point is. So in this way you can draw the shear force. Shear force diagram, so you can easily draw the loading diagram from there, and then after you can easily draw the bending moment diagram from this loading diagram. So for overhang beam, you have to draw the shear force and bending moment diagram in this way. You can also do the reverse process from shear force to loading, and then after loading to bending moment. So today we have stopped here. From the next lecture, we will consider the new topics.